All right, good evening. Welcome to section 6.3. We are talking about binomial radical expressions. Really what that means is we're going to learn how to add and subtract radicals and multiply them when they're written in binomial form. So the first thing you're going to need to know, I need you to write down, is what does it mean to be a like radical? It's just like terms. It's exactly like terms. X and x squared are not like terms because they don't have the same power. Like radicals are radical expressions that have the same index and the same radicand. The same index and the same radicand. So let's look here. This guy's radicand is 7 and his index is 3. So these guys are like radicals. They are like radicals. Let's come over here and look at this example. He's got an invisible 2 there, and so does he. He's a square root. And let's look at their radicands. 6xy is the same as 6xy. So these guys are like radicals. If we come down here and look at this example, these guys are bust. They are unlike. Why are they unlike? Because the square root of 6 and the cube root of 6 are not like radicals. Okay, so that's pretty much what we're going to be dealing with here. Let's go on to our next topic. So we're going to learn how to add and subtract radicals. What you need to remember is the only way we can do this is if they have the same index and same radicand. So we're going to take a look at a bunch of examples because I think it's the best way to illustrate it. So let's look at example A. I've got index of 2 and my radicands are 2x and 2x, so that's good. So what we do is we really treat the square root of 2x, we treat it like a variable and we leave it over here and we say, what is 5 plus 3? It's 8. I have 8 of them. So that is how this simplifies. Okay? Let's take a look at our next example. My indexes are the same. I've got a 3 and a 3. My radicands are the same. I've got a 5 and a 5. So all I'm going to do is take a look at these numbers on the outside. What's 8 minus 2? 8 minus 2 is 6. And I'm going to leave the cube root of 5 there. Okay, next example. My radicand is xy and xy. I have the same index, so I can simply subtract the outside pieces and I can totally ignore what's underneath the radical and just add it on. So 4x take away 9x means I have a negative 5x. And what's hanging off the back end here? An xy. Okay? And last but not least, my last example, I've got an index of 5, an index of 5. My radicands are 3x squared. So all I have to look at is the 17 minus 11. So 17 minus 11 is 6. And what do I have 6 of? I have 6 of the 5th root of 3x squared. That's how that simplifies. All right, next page. I'm going to ask you to add these together. And you're going to say, but Mrs. Brady, they're not the same radicand. And I want to tell you that you should always simplify first. Sometimes it looks like you can't, but you really can. So we know that 63 is, factors of 63 are 9 and 7. So what do I get here? I get the square root of 9 is 3 radical 7. And I know that 28 is the square root of 4 times the square root of 7. But the square root of 4 is 2. So that's 2 square roots of 7. So now I can go ahead and add these guys together. I can add the 3 and the 2. The 3 and the 2 give me 5. And I have 5 of what? I have 5 square roots of 7. So you always need to simplify first. Let's take a look at one of these guys. Something tells me that I'm probably going to have a radical 3 if one of mine is a radical 3 and he's prime. So I know that 12 can be written as the square root of 4 times the square root of 3. And I know that 75 is really 25 times 3. So when I go through here and I start to simplify everything out, the square root of 4 gives me 2 square roots of 3. The square root of 25 gives me 5 square roots of 3. And then I'm going to subtract a square root of 3. So there's my square root of 3. What am I adding up? 2 plus 5 minus 1. There's an invisible 1 there. 2 plus 5 minus 1 gives me 6. I get 6 square roots of 3. Okay. More adding and subtracting. These are harder problems. Because this is an index of 3, I want you to think of cube roots. Well, I know 250 isn't one of my cube roots, but I know that 125 is. So I can think of this as the cube root of 125 times the cube root of 2. I know that 54, it's got 27 in there, and I know that 27 is a perfect cube. So 54 is 27 times 2. And I know that the cube root of 16, I know I've got a whole host of 2's in there. So I know 8. The cube root of 8 is a perfect cube times the cube root of 2. So I'm going to go through here and simplify. The cube root of 125 is 5. The cube root of 27 is 3. The cube root of 8 is 2. Now I'm going to go back and write in my cube root of 2. There's a plus. Cube root of 2. There's a minus. Cube root of 2. So the only things that I need to add up are 5 plus 3 is 8. 8 minus 2 is 6. And that's what that simplifies to. It would be handy to have your list of perfect cubes and perfect squares out. You can also do that in your calculator. All right, let's take a look at this guy. The square root of 20, I know that this guy can simplify into the square root of 4 times the square root of 5. And I know 125 can simplify as perfect squares the square root of 25 times the square root of 5. So when I go ahead and take care of this, the square root of 4 is 2. The square root of 5 is 5. And I've got a square root of 5 left over and a square root of 5 left over. But I need to go through and make sure that I multiply this 6 times the 2. So I get 12 square roots of 5. And then I've got to go through and make sure that I take 3 times 5. So I get 15 square roots of 5. And 12 minus 15 gives me negative 3 square roots of 5. Okay? I think that's good. We're going to move on. I can save this one for class. All right. You guys practiced this in our polynomials unit. So we're going to multiply binomial radical expressions. We can FOIL because I've got 2 terms, or we can use the box method. I'm going to show you guys using the box method because I think it's a pretty clean way of keeping track of our work, and I like the organization in it, but it would help if I could draw a straight line, right? Okay. So I want you to give yourself a box and split them up. And across the top, I'm going to write 3 plus 2 radical 5. And going down the side, I'm going to go 2 plus 4 radical 5. And inside each cell is going to be the product. So 3 times 2 gives me 6. In this box, I'm going to take 2 times 2 radical 5. I get 4 radical 5. Then I'm going to come over here and I'm going to take 3 times 4 radical 5. That gives us 12 radical 5. This box, I'm going to do my side work. My side work is 2 square roots of 5 times 4 square roots of 5. So 2 times 4, those guys come together and I get an 8. And I get 8 times the square root of 25, which is 8 times 5, which equals 40. So I'm going to go ahead and put 40 in here. Now, write everything out and combine your like terms. What's interesting is I've got 6 and 40 go together. I've got a 46 plus, and then I've got a 12 and a 4, 16 square roots of 5. That's my answer. If you FOILed it, you should get the same answer. So that's how we find the product, by FOILing. My last piece is to talk about the conjugates. You guys have practice with this from last unit, and you know something really special that happens. These I'll rainbow out for you guys. So we're going to double distribute or FOIL. 6 times 6 gives me 36. And then I'm going to do 6 times positive radical 12. So that gives me 6 square roots of 12. Then I'm going to come through and do my second part. And the reason this is going to all disappear is because these are conjugates. I get negative 6 square roots of 12. And then my last term is going to be minus the square root of 144. Well, what's really nice is that disappears, which we remember, and I get 36 minus the square root of 144 is 12. So that equals 24. So my answer is 24. So whenever I multiply it by a conjugate, I'm going to end up with a real number. It's not going to have a square root in it anymore. So the reason we had to learn how to do that is so we can rationalize the denominator. When we've got a binomial radical expression in the denominator, we need to rationalize it because we can't have a square root in the denominator. So if you remember before, what we used is we took the denominator and multiplied by itself. Well, in this case, because I've got a binomial, I need to use the conjugate. So I'm going to use 3 plus rad 6. And remember, this is a fancy way to write the number 1. So I'm going to put 3 plus rad 6. And now as I multiply across, 4x times 3 gives me 12x. And then I'm going to take 4x times radical 6. So I get 4x rad 6. Now, if I go ahead and multiply in the denominator, I get 3 times 3 is 9. I get 3 square roots of 6. I'm going to write this out here. 9 plus 3 square roots of 6 minus 3 square roots of 6 minus 6. So what drops out? And I end up with 9 minus 6. Well, 9 minus 6 simplifies to the number 3. So I'm going to go back in and put 3 here. So with a rationalized denominator, this is what this looks like. My answer should be 12x plus 4x rad 6 all over the number 3. Okay? That's my answer. Okay, tomorrow in class, please be ready to do the following. I want you to be able to subtract like radicals. I'd like you to subtract like radicals even though you look like you can't. And I'd like you to figure out for me, how could you figure out a way to prove that this is not true? Okay, that's it for me. Have a good night.